Hi there, and welcome to this episode on this topic, the mole concepts, where we're dealing with solutions and concentration. So let's see what we've got in today's lesson and see if we can do justice to a thing or two. So we're beginning today's lesson with a concept that is called molarity. Let's define it and let's know what it means. Now, molarity is simply a concept that talks about how many moles are present in a certain volume of solution. Now, here is an example you can relate with. If you have a group of people, like I have a diagram of a group of people over here in a particular place, the more the people are increased or the more people that are added to that space, the more crowded that place is. So that is the meaning in plain language. Molarity is simply asking you how crowded or concentrated a solution is, because the more of solutes that we have in a solution, the more concentrated it becomes. So basically, that's the concept of molarity. It talks about the concentration of a solution. So here is a relatable example that you should be able to understand. If I put 1 spoon of sugar in water, mm, it tastes like that. You might not really notice the taste depending on how much the water in the cup is. But when I begin to increase the number of spoons of sugar, increase it to maybe 5, the taste becomes stronger. Why? Because that solution is becoming more concentrated. So the more particles you have in the same amount of space, the higher the concentration. So concentration and molarity are simply the same thing. So we're talking about the amount of solute that we have in a solution that dissolves it. So I trust the concept is very much clear now and you understand what I'm talking about. So here is an example that breaks down what I am talking about. I have a question on the screen right now that starts off by saying, what is the molarity of a solution containing 0.5 moles of salt in 2 dm cube? Okay, so there is a formula to deal with that, okay? The molarity of a solution is given by the number of moles of that solution divided by the volume. Now, that volume must always be given in dm cube or liters. Okay, because molarity is measured in moles per dm cube. This is also the same unit that we measure concentration with in chemistry. So the number of moles that we have present now is 0.5. So let's write that down. 0.5 divided by the volume. We have 2 dm cube. So 0.5 divided by 2, that gives us 0.25 moles per dm cube. This is the molarity or the concentration of the solution. Did you see how that was carried out? I trust you're enjoying every bit of today's lesson. So now, here is a caveat that you need to put into consideration. Using the volume in dm cube, many students lose marks because of this, because they forget the units. Okay, so molarity always works with volume measured in dm cube or in liters, not in cm cube. Using cm cube would make you lose a whole lot of marks, and that's not what we want to happen. So here is a conversion rule. Let's say you have a question that gives you the volume measured in cm cube instead of dm cube. What do? You simply divide that amount in cm cube by 1000. It will give you the volume in dm cube, because basically 1 dm cube is equal to 1000 cm cube. So in order to convert from one unit to another, you divide the cm cube by 1000. Okay, so here is an example on the screen. If you have A question that asks you the molarity of a solution that is in 500 cm cube. The first thing you want to do is to convert it from cm cube into dm cube. And how do you do that? You simply divide 500 by 1000. That will give you 0.5 dm cube or 0.5 liters. Whichever one you choose to use is absolutely fine. So that being said, let's move on to the next topic in today's lesson that we want to deal with. It talks about dilution. Now, we've talked about concentration. One other concept that is very important to master in the concept of concentration is dilution. Now, most of you or all of you watching this video have already heard this word dilution before. So, what does it mean in the concept of chemistry? Dilution simply means adding more water. It is as simple as possible. Maybe you have a bottle of juice, a bottle of some soft drink that tastes very concentrated, and you don't want to take as much concentration as the bottle is offering you. You want to make it lighter. One of the ways to do that is simply to put a particular portion of it in a glass and then add some water to it. It makes it less concentrated. So that's the concept of dilution. It means adding more water to a solution. The number of moles stays the same. That is, the amount of the solute that has been dissolved is the same. It doesn't change. Only the volume of the solution changes. Now, when the volume of the solution changes, the concentration will also change. Now, here is a formula to deal with that. We have M₁V₁ is equal to M₂V₂. Now, all these acronyms here have meanings, okay? So this M1 here stands for the initial concentration or the initial molarity, okay? And then this V1 here stands for the initial volume. So what this means is before the dilution took place or before dilution takes place, there is an initial concentration that the solution had, and there is an initial volume that it occupied. And then after the dilution take place, there is a new concentration or new molarity, whichever word you intend to use. And then there is a new volume that is now occupied by the solution. So all this can be calculated by this dilution relation formula. M₁V₁ is equal to M₂V₂. Now let's solve a question to put into practice what we have just talked about. But before we do that, here's a relatable example to help you digest what I just talked about. Let's say you have or you added more water to juice. Okay, I have a cup of some juice here on the bottom right part of my screen. When you add more water to juice, what happens? The sweetness of that juice reduces, but the amount of sugar that was there did not reduce or increase. It remains constant. So the sweetness is reducing because the water is increasing. So that means the concentration also is changing. So let's check out a few examples, one or two of them. A solution of 2 moles per dm cube, okay, has a volume of 1 dm cube. It is diluted to 4 dm cube. Find the new concentration. So the first thing to do would be to write down our formula. M₁V₁ is equal to M₂V₂. So let's give the values to each variable. We have M1, which stands for initial concentration. What is the initial concentration in this case? A solution of 2 moles per dm cube. That was the concentration before it was diluted. So we have 2 moles per dm cube as the initial concentration. Now, V1 stands for the initial volume. It has a volume of 1 dm cube. So let's write that down as well, 1 dm cube. It is diluted to 4 dm cube. That becomes the final volume. Okay, so we have 4 dm cube. Find the new concentration. That means M2 is unknown. So now we can plug our variables into the equation and find our answer. So we have M1, which is 2 moles per dm cube multiplied by V1, which is 1 dm cube, is equal to M2, which is not known, multiplied by V2, which is 4 dm cube. Can you see how everything is playing out now? So we have 2 multiplied by 1, that gives us 2. This is equal to 4 multiplied by M2. So what do we do at this point? We simply make M2, which is what we're looking for, to stand alone. You do that by dividing both sides by 4. So 4 cancels 4. On the other side, we have 2 over 4. 2 over 4 is the same thing as saying 1 over 2, which is 0.5. So M2 becomes 0.5. What will be the units? Remember, molarity is measured in moles per dm cube. This is the new answer, or the new concentration that we've been looking for. So that brings us to the next topic we want to talk about in this video, which is the titration mole relationships. Don't worry, we won't be going in depth into this one, okay, because the video has become quite lengthy already. But at this point, we want to talk about the combination of mole ratio and concentration. Now, titration is one concept that comes up in terminal examinations like WAEC, NECO, and the rest of them, where you get to make your hands busy through practical chemistry. So we have a formula that is very, very, very important to know. Okay, we have M₁V₁ divided by N1 is equal to M₂V₂ divided by N2. Each of these variables have what they mean, okay? And we're going to be going in depth into each of them. But just have that at the back of your mind that for titration calculations and questions, that is the formula to be used. So here is a step-by-step method for handling scenarios like this. The first thing to do would be to write the balanced equation. Then the second thing to do would be to collect the values for, let me just give the breakdown of what each variable means. M1 simply means the concentration of the acid. Okay, V1 means the volume of the acid. N1 simply means the number of moles of the acid. Now, this is gotten from the balanced equation that is given to you from the beginning of the question. Now we have M2. This stands for the concentration of the base. And then we have V2, which is the volume of the base. And then N2 was the number of moles of the base. Okay, so that's what each of them means. You collect the values, you put the coefficients, and you solve. We're going to be going in depth when we get to the exercise part, okay? So here are some exercise questions for you to try out your hands on from what we've talked about in today's video. This is the first section. We have 2 for you to try out your hands with. Here is the second section. And then here is the third section. Don't worry if you're having trouble handling any of these questions. There is an exercise portion that has been wholly dedicated to showing you how these questions can be handled. So with that being said, we've come to the end of today's video. And up next, we're going to be looking at the rapid revision for this topic, the mole concept. I hope it's been a jolly ride for you. It has been for me, and I'm so excited to have you stop by and listen to what I've got to teach and say. With that being said, I'll see you in the next video.